Let's take a look at lesson 40, looking at abstract fractional equations. So you've had fractional equations in the past, they just had numbers, and you solve for numbers, or just one variable. Now we have all variables, all letters. So in example 41, it says solve for x. Okay, well x is on the bottom. So how do we get x by itself? Right now, it's solved for c. Okay, so we got to switch this thing around. So what we need to do first, step one, is to find the least common multiple. Least common multiple to cancel denominator. Abbreviate. To cancel denominator. So here, what is our least common multiple? Okay, our least common multiple would be, well, we have an x and an a, so it'd be those multiplied together. So xa. So what we're going to do is multiply each, column, however you want to look at it, by x times a. And now what we have here is when we multiply by x over a, okay, let's look at it this way. Do an a over x times x over a. Well, what we have is the x's can cross out, okay? Because in a sense we are multiplying each one by what it is missing. So the x's cross out. Now notice that would leave us with a denominator of 1. We would be left with a squared. You could call it over 1. I'm not going to write the over 1, but that's what we would be left with. So we're not finding a least common denominator. Least common denominator means you keep a denominator. Least common multiple means you will cancel the denominator. You can only do least common multiple. There is an equal sign. There has to be an equal sign. So in this case, we can use it. So let's find the least common multiple of the other ones. So we got a squared for there. Okay, the a's would cancel. So it'd be plus xm equals, and you do have to do it to every single one of them. So it would equal cxa. And we are solving for x, I believe. Yes, solving for x. So the next thing we want to do, okay, step 2 is get all of the variable on one side. The variable looking for on the same side. So we are looking to solve for x. So since we're looking to solve for x, we need all the x's on one side. Dangerous. But we would do the opposite here. Subtract xm, subtract xn. So this goes out. So we get a squared equals cxa minus xn. Now, okay, you may be wondering why we did this. Well, why we got all the x's on one side is because now we can factor. We can factor out the x and say, so we took the x out of both of these, and let's see what we are left with in parentheses. Well, we'd be left with ca minus n. So this is just factored. Now we have a squared, now we have x times this expression, so we can divide ca minus n. So our answer would be a squared over ca minus n equals x. And that would be our answer. And that is solved for x. So let's do one more, solving for p. Start with our same steps. Step 1, find the least common multiple. We only have a p and a y, so our least common multiple is py, pi. And we got to multiply it to all of them. Okay, let's see if anything cancels out. P's cancel. So you're left with 6y. Nothing cancels there, and no denominator. Minus AXPY equals y's cancel equals PM plus KPY. And we are solving for P. Step 2, get all the P's on one side. Here's a P, there's a P, there's a third one. So this one's on its own, this one has 2, so I'm going to go ahead and add this one over here. Press out. So now we have all of that equals 6y. Now, just like we did in the last one, we can factor the P out and be left with M plus KY plus AXY. 6y equals P times all of that. P is by itself in a sense now. It's got a product, so we can divide by all this to both sides. So we would get, I'm just going to draw an arrow. So we would get 6y over M plus KY plus AXY equals P. And that's how you do these abstract fractional equations. Find the least common multiple to cancel the denominators, and then get all the variable that you're solving for on one side. Factor, divide will generally be the process.